Welcome to this explainer. Today, we're embarking on a data rescue mission. I want you to step right into the shoes of a SOC analyst, specifically working at a managed security service provider called CyberTease Ltd. We've got a massive challenge on our hands. We need to take raw, totally chaotic machine data from a custom source and somehow transform it into clean, perfectly searchable insights. And here's the catch. We're not going to just click around some graphical interface. Nope, we are going deep beneath the surface to master Splunk's core configuration files.
So, here's our blueprint for this mission. We'll go step by step. 1. Taming raw machine data. 2. Ingesting and directing logs. 3. Defining event boundaries. 4. Masking sensitive information. And finally, 5. Extracting custom data fields. Let's get right into it.
Okay, let's dive into this. Section 1. Taming raw machine data.
To prevent any confusion down the line, we really need to define one absolutely critical term right off the bat, and that's the stanza. So what is it? Well, a stanza is basically just a section inside a Splunk configuration file that kicks off with a text label inside square brackets, something like VPN logs. Think of it kind of like a header. It tells Splunk exactly what component all the following settings actually apply to. Whether you're dealing with an index, a source type, or a field transformation, the stanza is literally the core building block of every single configuration file we're going to touch today.
We'll be working with 4 main configuration files, and honestly, the best way to think about them is like the rules for a really strict club bouncer. First up, you've got inputs.conf. That's the bouncer's guest list. It dictates exactly what data is even allowed to get in the door. Then there's props.conf, which tells the bouncer how the guests need to behave and group up once they're actually inside. This handles our parsing and processing. Next is transforms.conf, which dictates what they need to hide or how they should be enriched. And lastly, fields.conf. This one basically hands out the specific name tags so we can easily identify everyone in the club.
All right, moving right along to Section 2, ingesting and directing logs. Before we can do anything cool with our data, we actually have to get it in the door, right? That brings us back to our guest list, inputs.config. This file is where we instruct Splunk on exactly where our custom Python scripts and logs are coming from. Say we have a log-generating script sitting in our app's bin directory. We specify that exact path right here. We can also set the interval. Maybe we want to run this script every 5 seconds. And we assign the basic metadata. We tell Splunk, hey, this is the source type, and funnel these logs into this specific index, like the main index. Without this file, Splunk is completely blind. It won't see a thing. Which brings us to Section 3, defining event boundaries. So the crucial point is that getting the data in the door is really only half the battle.
Let's look at a real emergency. Imagine we just ingested some custom VPN logs and Splunk is absolutely panicking. It's grouping 10 separate log lines into one massive, unreadable mutant event. As an analyst, you can't search that. You can't correlate that chaos. We have to fix it, and fast. So we step into procs.conf under our VPN_log stanza. First thing we do, we set should_line merge to false. This explicitly tells Splunk, do not combine these lines. Then we use a simple regular expression. We set must break after equal to connect or disconnect. Why? Because we noticed every single line in these logs ends with one of those 2 exact words. So we use them as the trigger to cleanly slice the events apart.
And this brilliantly illustrates the exact before and after of our configuration. We go from chaotic, clumped-up data to perfectly structured single-event logs. We've successfully told our bouncer how to separate this rowdy, disorganized crowd into a neat, orderly, single-file line. Each user action is now cleanly isolated and totally ready for analysis. But wait, what if our logs are actually supposed to span multiple lines? Think about complex authentication logs, right? You might have a timestamp, a department, and an action, all sitting on completely different lines. Well, for this, we just reverse our logic. Back in props.conf, we set should_merging to true. Then we identify a starting pattern. Let's say every new login attempt starts with the word authentication in brackets. We just set break_only before to that exact string. And just like that, Splunk will beautifully merge all the relevant lines together until it spots the next trigger word. Now things get a bit more intense. Section 4, masking sensitive information. The stakes are getting much higher here. Our next batch of custom log data contains a massive security risk that we absolutely have to neutralize. I want you to ask yourself, what happens if sensitive customer credit card data from our purchase logs is ingested into our system in plain text? Think about the real-world consequences of that data just sitting there, fully visible for any analyst to stumble across. The reality? It's a total disaster. Leaving this data unmasked directly violates the Payment Card Industry Data Security Standard, or PCI DSS. That puts the entire company at risk of severe noncompliance penalties, and far worse, it exposes real customer financial data to unauthorized users. This isn't just about making our data look pretty anymore. This is about protecting the business. We literally have to mask this data on the fly the second it's ingested.
Now, what's really interesting about this next command is how we actually pull that off. We solve this using something in props.conf called sedcmd. It's based on the Unix command sed, and it uses a regular expression to actively hunt for hyphens followed by blocks of 4 digits. The moment it spots a credit card pattern, it immediately substitutes those numbers with blocks of X's. By applying this one simple line of code to our purchase_log stanza, the last 12 digits of every single credit card are masked instantly, before they are ever even indexed. The threat, completely neutralized.
Which leads us to our final stop, Section 5, extracting custom data fields. Okay, so we've tamed the logs, we've broken the events apart, and we've secured the sensitive data. But honestly, just having the raw text masked isn't quite enough. We need to extract specific values to make these logs truly searchable for a SOC analyst. Let's jump back to those VPN logs for a second. If you look closely at the raw text, there are 3 distinct, incredibly valuable pieces of information trapped inside every single line: the user who connected, the server they connected to, and the action they actually took. Right now, Splunk just sees a dumb block of text. We need to isolate these 3 fields so we can actually build out dashboards and run alerts based on them. To give our data these custom name tags, 3 of our configuration files have to interlock perfectly. Here's how we do it. Step 1, we go into transforms.conf. Here, we write a regex pattern that captures the user, server, and action, and we define the format so Splunk knows exactly what to name them. Step 2, we jump over to props.conf and use the transform setting to link our custom extraction back to the VPN logs source type. Finally, step 3, we crack open fields.conf and set those brand new fields to index equals true. That tells Splunk to make them fully searchable. And here is the payoff for all that back-end configuration work: 14. After setting up similar custom extractions for our secure purchase logs, we can search our index and instantly see 14 perfectly extracted user field values. We successfully reached right into the raw text strings and isolated the exact names of the users making the purchases. And even better, consider this final metric: 4. We successfully extracted 4 unique, fully masked credit card number fields. This proves that our data pipeline is completely functioning. Our data is highly structured, deeply searchable, and yet completely secure and compliant. We did it. We rescued the data. We've reached the end of our mission, and I really hope this brilliantly illustrates that while fancy dashboards are great, the true power of a SOC analyst lies beneath the UI, right there in the configuration files. By mastering inputs, props, transforms, and fields, you can conquer absolutely any data chaos thrown your way. So I leave you with this: what messy data will you rescue next? Keep exploring, keep learning, and I'll catch you next time.